Alright, so remember that we looked at our first couple of cases with our law of sines, and now we need to look at our next two with our law of cosines. So remember that if I have two angles and a side, so that's angle, angle, side, or angle, side, angle, or if we have two sides and the opposite angle, so side, side, angle, all three of those cases were our law of sines. Today we're going to look at our last two cases, which are going to be using the law of cosine. And just like it says in the name, instead of having sines in our equation this time, we're going to have cosines in our equation this time. So here is our law of cosines. So what does our law of cosines look similar to? It does. And let's think about if I'm looking at like that first one, right? A squared is what's going to be across from cosine of big A. Yeah? Well, let's pretend that my A squared is our hypotenuse. And so then what would big A be? 90. And what is cosine of 90 degrees? Is 0. So notice that that second part, the minus 2bc cosine of A, would all go away. And we're just left with A squared equals B squared plus C squared, which is our Pythagorean theorem. So basically your Pythagorean theorem is just a specific case of law of cosines. But we can only use our Pythagorean theorem when we have a right triangle. We can use law of cosines for any triangle. So let's look at an example. So which case do we have here? Side, side, side. Now, did you notice on our list what case we don't have as an option? So we had two angled and side. We had two sides and an angle. We had all three sides. We do not have one that has all three angles. Why not?
Because they don't know any of the signs. It's
Correct.
harder to really tell.
You could have
Correct. So like two triangles that have all three angles that are the same are what kind of triangles? Sorry, not like that the angles themselves are equal, but like if I have two triangles and their angles are equal to one another. They're not congruent, because in order for me to congruent, their angles and their sides would have to be equal, right? They could be similar, yes? Because like I could have 1, 2, 3, and then 2, 6, 9, right? So like they're gonna be proportional to each other and have the same angles. But we can technically have an infinite number of triangles, right? Because like my angles stay the same, but I can just scale it up or scale it down. Which means that if I have all three angles, I can't solve for those because they can technically be an infinite number of things. Which is why angle, angle, angle is not a case that we can solve for. We just don't have enough information. But in this case, when we are looking at side, 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 notice that since I don't have an angle, we don't have enough information to to create a full fraction in order to be able to use our law of sines, which is why we have to use the law of cosines. The other thing we want to notice is that we always want to solve for the biggest angle first. And that just helps us to not create an ambiguous case for our law of sines. So in this case, my angle B is going to be my largest angle, because remember your largest angle has to be across from your largest side. So then I'm just using that formula. So we have B squared equals A squared plus C squared minus 2AC cosine of big B. So then we're just going to plug in. I have 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times cosine of big B. What are we solving for there? Big B, okay? So the biggest thing that people run into with these problems is trying to plug too much into their calculator all at the same time, okay? So I would recommend simplifying some stuff first before you start trying to solve for big B. So, first, what is 19 squared? Okay. And then 8 squared plus 14 squared?
216.
And then 2 times 8 times 14? 2 what?
224.
Okay. Can I subtract my 260 and my 224? No. That's the other mistake that people will make, is that they want to subtract these two. But notice that my 224 is connected with my cosine of B. Okay, it'd be like if I had 4 minus 2x, right? One of them has an x, one of them has something else, so they cannot be combined. Yes, ma'am.
So why do we decide to like solve for this one? We just chose
Because
that
it's the
one.
longest one.
Okay.
I need to solve for my biggest angle first. Because remember that if I have a triangle, I'm only allowed to have one obtuse angle. Yes? So if I solve for that obtuse angle first, then I know my other two have to be acute. Because we're trying to not create an ambiguous case, right? So we want to make sure we solve for the biggest one first. Alright, next up, what do we want to do? Okay, and get. Okay. And then what would we do?
We divide by negative 224.
Mm-hmm. And then lastly, our big B is inside of a cosine. So instead of sine inverse like we did previously, we have to take cosine inverse. And again, that big B is approximately you get 116.801 degrees. Okay. So now that I have one of my angles, do I need to use law of cosines again? No, because we have enough information now to set up a full fraction, yeah? And you can use law of cosines again. You would do the exact same thing, but with one of your other angles, alright? However, most of us tend to like just the fraction more than having to square all the things. So, we tend to use law of cosines for the first one, and then use law of sines for the second one. So it doesn't matter which angle we want to solve for next. Sure. So again, I'm using law of sines this time, so I'm going to have sine of big C over 14. I have to use my b's because that's the only angle that I have right now. So I'm going to have sine of 116.801 divided by 19. So then what would we do to solve?
over 14.
Okay, and
Keep the cosine.
sine inverse?
Yes.
Okay, so I have sine inverse of 14 times sine of 116.801 divided by 19. Huh? 41.24? Okay, which makes sense because again, B ended up being an obtuse angle, so C and A have to be acute angles. Do I have to use law of sines again? No. What can we do now?
Subtract from
Just subtract from 180. So I have 180 minus B minus C. What do we get? What? 5. Sounds good. Well, now those are my other two. What questions do we have? Like I said, I mean, we have to know the formula, but like I said, the only difference between this one and like our law of sines is that there's a little bit more simplifying with all the squares. But other than that, it's not like super difficult. So let's look at a side angle side case. So this says find the remaining two angles. We're just gonna stop there. We'll find the two remaining angles. Because again, the side would be another law of sines, but we've practiced plenty with that. So now notice again, even though I have an angle this time, I don't have the side that's across from it, and then I don't have the angles that are across from my other shoe. So I couldn't use law of sines because I don't have enough information to create a full fraction again. So we would have two unknowns, and so we can't solve for anything. So that means in this case, I have to solve for, sorry, not the other side. We want to solve for the side first. We're just not going to solve for the other angles. So we're going to solve for that little a, okay, which means that we're using a squared equals b squared plus c squared minus 2b minus c cosine of big A. So I have 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25 degrees. We don't have to do as much solving this time, but I would still recommend going ahead and simplifying a little bit. Okay? So 9 squared plus 12 squared gives us
225.
okay. And then 2 times 9 times 12 gives us
216.
okay. We're just gonna leave the cosine of 25 there. And then what would I have to do in order to solve for A? Square root it. So we have the square root of 225 minus 216 cosine of 25 degrees. You're going to plug all of that in. And what do we get?
5.407.
And we're in medium. So that's going to be my answer. So what could we say about the other two angles? Huh? Maybe. We at least know that they both have to be bigger than 25, right? Because little a is my smallest, right? Which means that I know that my other two have to be bigger than from 180 again to find the third angle. Yes, maybe. Alright, let's look at a word problem. So it says, the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet, as shown in the figure. The pitcher's mound is not halfway between home plate and second base. The reason that they say that is because if this was halfway, then that would make this a right triangle, which kind of defeats the purpose of this unit. Okay? But they ask us to find how far the pitcher's mound is from first base. So we are looking for H. Okay. So which case do we have here? Side, angle, side. So do I have enough information to create a full fraction for law of sines? No, because I don't know H, so I can't set up the sine of 45, and I don't know either one of my other angles in order to set it up with F or P. Agreed? So, what do we have to use? Law of cosines. Now, these are different variables than our A, B's, and C's, but the format of it still works the same. So I have an H squared equals my other two squared, so plus F squared plus P squared minus 2FP cosine of big H. Right? So it doesn't matter that they're different variables, okay? It's still going to be in that same format. So really you only need to memorize that first one, and as long as you can kind of memorize the format, then it works for whatever variables we have. So we know that F is 43, P is 60, and big H is 45. So what is 43 squared plus 60 squared? They're going to be big numbers. 5,000 what? 49. Okay. 2 times 43 times 60. 5,000. Okay. And then I saw cosine of 45. And then what do I need to do in order to solve for H? Square root that. What do we technically have to have in our equation whenever we take the square root of something? Plus or minus. But our H represents what? A side length? Can we have a negative side length of a triangle? No, which is why we end up not caring about it. So then we type all that in our calculator. And what do we get for H? 42.430. And we're in so we can say that since little h is very, very close to little f, right? That means that this is going to be pretty close to 45. So this is going to be close to a 90-degree angle, right? Because it would be 45, 45, 90, but it's not quite, okay? Which is why it says you can't assume that it's halfway, because it's not quite going to be a right triangle. What questions do we have there? So this is a good example of a nice application problem for our law of cosines. And we're really looking at an application problem for our law of sines. And remember that that's what your project next week is going to be over, is creating your own application problem for either a law of sines or a law of cosines. You do get to pick which one you want to do.